I'll do something that everybody's favorite problem. Trains. You like trains? How many people love trains? Oh, so I am doing something that's everybody's favorite problem. All right, good.
Love trains. That's a different kind of drink.
Okay. Okay, real world problem. Really real world. Two towns with two parallel train tracks. Right? That's how realistic can you get? And you have two trains operating one on one track, the other on the other track. They're going in opposite directions. So this is train A and train different tracks. Now don't give me this thing about
two tracks.
Two tracks, right? Parallel, same distance, everything the same. Right? So train A is constant speed. Let me see. We get the numbers right. 60 mph. And train B, okay, train A. Train B, constant speed, 50 mph. After how many hours do they need? You saw it coming, right? Oh, yeah, I can tell you the distance. This distance is one, 1320. The distance between the two towns is 1,320 miles. So after how many hours? Will they meet? Now every textbook gives this problem without saying the parallel tracks, and students are going to get nightmares about it. Right? So I've learned a lot since then, and make sure you know that no, we're not planning an accident. No. Well, it's what's more important is how you think about this. Okay. First of all, do you all know how? Do you all know the answer? No. There's a template. Oh yeah, you do. There's a template for this kind of problem. There is. I'm not going to tell you if you don't know.
Oh.
All right, Sandy, what is the answer? Huh?
I'm doing what you said, I'm trying to figure it out.
Oh.
I don't know how.
Okay, well, we go through that. That we can go through. Not the template. Is this your favorite train problem? It is. Okay.
1.4 hours?
Nope. What you do? You're chickening out. All right. Anyone has any ideas? How we can approach it? How to think about these things? Okay, Leah?
So they're together moving in 110 miles each hour.
Mm-hmm.
So you want to find out how many 110s fit in that 1320 are in that
Exactly.
number line.
Exactly. Yes. That's all. That's it. Right? So long. In 1 hour, they travel a total of 50 to 60 miles, right? But this is why you have to know the exact meaning of constant speed. It means 1 hour you travel that long, right? You cannot depend on keyword. Now I'm not talking about you. I'm talking about students who are taught to watch for keywords without understanding anything. There's no way they can do problems like this because. Right? So in 2 hours, they travel a total of 2 miles, right? And so on. And in T hours, they travel a total of T times 50 plus 60. What do you want? What do you want in such terms? What do you want? What do you want? No, I mean, tell me, no, don't just say T, tell me in complete sentences, what is it you want? What? Yes, how many hours they do what? What does it mean they meet?
They travel 100.
They travel the whole distance, right? So, after 1 hour they're here, 2 hours they're here, 3 hours they're here. What you want is a certain number of hours they meet. That means the total distance traveled is now what? 12, 20, 13, 20 miles. Right? So that's all. So let us say, right? Let us say they meet after capital T hours. Right? As we said, right? That means, so that means what? That means capital T times 50 times 6 plus 60 is equal to 1320, right? What does it say? Look at this equation. What does it say? What is this statement? What is this statement? What is this statement?
This is this division?
Division.
What?
Division.
Why is it division? What division?
Whole number then.
Whole remainder.
Definition of the whole number.
What's the definition of division again? It's exactly the same as what? K? It's entirely the same. Completely, 100% the same. Right? So, you see this, that means what? This, the K is the T here. N is 50 plus 60. That is 1320. What do we call it? 1320. And that is why what's the answer?
12.
Well, exactly.
So how do we know that there won't be a remainder?
Now, you see, this is why I try to explain to you. The only reason we can discuss such problems is what? You fix the unit of time, you're not going to discuss fraction times.
Oh, okay.
This is a priori guaranteed that these things have to work out by pure division. In other words, you know ahead of time the answer is not going to be an hour left over. We can't afford that because the only reason we can talk about constant speed is that everything is given to you as whole numbers. So such problems, at this point, it's already given to you. I've ripped everything so that it must come out as whole numbers. Otherwise, the whole discussion is completely meaningless because when we come to fractions, you have a whole lot more problems. And right now, as I said, this is fourth paradigm. No, it's not really what it is, but yeah, but we can work with it now. See? So that's why you have this paradigm. So you don't worry about remainders because you just know that it doesn't happen. Right? Now you must have been given templates of this nature. When you paint a problem like that, add the speed and divide, right? Now, don't do that. Don't do that. Don't ever do that. It's simple enough, provided you put in the hard work to explain what division is, what constant speed is. And that is what people who write standards, people who write textbooks, don't want to do. They give you a little hand with this because they think in the back of their mind what they think is it. This is one formula. You can teach it in half an hour and then you can go on. The Common Core standards are beginning to pay attention to such things. And it's a much, much, much more reasonable set of standards than anything we've ever seen. So that's what it is.